Hello, welcome to the marking video, I guess, or the lecturer react to student answer script video. Gotta market it to the times what. Okay, so here I will mark a few sample scripts from different candidates. Not going to tell you who these people are, confidentiality. And I'll comment alongside the mark scheme and the examiner report to give you some tips to avoid losing your marks all the time. So, yeah, don't be blur. Okay, so I've already discussed the question, so I'm not going to talk about the question. I'll jump straight into marking. So this is a pretty straightforward 1 mark. So it's either you got or you don't have lah. Okay, if you don't know how to linearize the graph, go watch the other videos. Alright? Okay, we're going to jump straight to the table. Okay, so whenever you read the mark scheme, you see this T1, T2 mark. This T1, T2 must exist inside the table. So if for some reason, I don't know why, you're going to write 1 over d square at the margin because you feel like you want to express your creative placing, then you get 0 mark lah. So this one must exist inside the table at an appropriate location. So looks okay, can already, you transfer it over. Okay, look at all this number. So you notice that Gigio, you either have everything maintained to 2SF or everything maintained to 3SF. Okay, because if you look at the the examiner report, nearly all candidates were awarded credit for column heading. Of course, dude, we are transferring this thing to here. Even you cannot even copy this thing to here. Maybe get new glasses. Time for a glasses check now. Okay, so since the raw data given is to 2SF, I'll highlight this because this is important. Okay, a common mistake in the 1 over d square column was stating the last value to 4SF. Raw data is given to 2SF. So your 1 over d square must be 2 or 3SF. Wow, this one very familiar, right? This is from paper 3. So this is a common practice whenever you do table values. Alright, so just be aware, 2 or 3SF. The majority of the candidate calculated the absolute uncertainty correctly. A common error is not doubling the percentage uncertainty of d square. Okay, so for this one, if you look at this, all values to 2 to 3SF allow a mixture of significant figure. So how much the examiner will deduct marks here, it really depends on, I guess, the examiner. If you follow mark scheme, is a bit grey. I could say that everything must be 2SF or everything must be 3. But here they say allow 2 to 3 and also allow a mixture. So I guess this one I can give mark lah if I'm feeling nice. Okay, but don't let them treat you that way. Alright. Okay, so I think my laptop is plugged in. So should be fine. I shall just carry on as normal. Let me know if I'm lagging, by the way. People in the chat. Okay, so I'll continue. Where was I? Alright, so this one is correct. You can give yourself 1 mark. If everything is written to 2 to 3SF, you want to play it safe, this one should be 14. So I would be happier if this is written as 14. Okay. Alright, the reason why 14 is preferred is because you want to maintain consistent SF. So I'll write this here. Consistent SF. So if everything is 2, then everything is 2. Everything is 3, then everything is 3. That will be the safest way to go. Okay, U1. U1 here means it doesn't have to be on the table. So if you make a calculation error here, you and then you write outside, it's okay. It's okay, no problem. Okay, because I think CAIE understands sometimes students make calculation error lah. Alright, so normally the uncertainty in this case, if you are doing the right thing, it should be in some increasing or decreasing order. Like from here, it will go from 0.03, because if I round 0.026 is 0.03 to plus minus 1. So all this one is okay. Alright, so allow more than 1 SF. Okay, sure. Allow 0 for first uncertainty and up to 1.2 for the largest uncertainty. So for this one, right, they kind of like very lenient with you. This year is a bonus year. So you can see that generally I will also double check. You see, here I'm having a bit of a problem because this one is 1 decimal point. This one is 3 decimal point. Teacher screams internally. So in this case, you need to maintain the same decimal point. I will not give this mark. Okay, not because this is far away. I'm just going to minus 1 here simply because the decimal point of the absolute uncertainty and this 1 over d square is too far away. Cannot 3 and 1 lah. Okay, so just remember, I mean, if let's say you want people to have leniency, then 1 and 2 can, but also again not preferred. So the best way is to look at the model one that I've done. Try just write 1 lah, 1 SF. Why you want to give yourself a headache by writing many SF? Okay, easier to plot also ba. Alright, so let us continue. So this one is 3 mark lah, so the person get 2 out of 3. Plot a graph of this against this. Include error bar. Okay, boss. Let's go stare at the graph. Oh, looks easy. 6 points plotted correctly. So 1, 2. How do they know? Everyone have the same graph lah. So after marking hundreds of graph, we can close our eyes and point to the screen and see where the points are already. Okay, so I'm going to zoom in a bit, which if I'm a CAIE marker, I will be able to do as well. And I will notice that this one here, there's no error bar. Nani? Okay, so I can see 1, 2, 3. We'll check all the plots. You need to make sure that the plot points are small. So I'm going to once again assume that all the points are plotted correctly lah. Okay, so must be within half a small square. Do not allow blobs. Okay, and if you have any table values that are wrong, we will also allow that some ECF lor. So 6 points plotted correctly. I think this one okay. So the plotted point will get 1 mark. Error bars in 1 over d square correctly. All error bars to be plotted. Length of error bar must be accurate to half a small square and symmetrical. Okay, so in this case, if I cannot plot 0.03. This is why they say allow 0 for first uncertainty. So if you don't want to draw the last error bar, can. Because 0.03 is impossible to draw. But here you must declare it as 0 lor. But it's kind of risky, right? Because it's also a little bit anomalous. So this is fine because candidate didn't draw. You want to draw 1 also can. It's not really a problem. Okay, just make sure you draw all the error bars. You might think that it is inaccurate, but that is because that's the smallest error bar that you can possibly draw. Alright, so I'm assuming everything is correct. Again, it will be pretty straightforward and easy to tell if the candidate draw wrongly lah, or if the bar are not symmetrical. This is the things that we check for. Line of best fit. This is the interesting part. Every mark scheme is different. Okay, every question, every year is different. So they will provide the invigilator matrix like coordinates. So the examiner will have certain coordinates and you must pass through these points. So 2.6, 4.0, 3.0, 4.0. Where are they? 2.6 to 3.0. So if I look at my graph, 2.6 is here. 2.6, this is 2, 2, 4, 6. So 2.6, 4.0 to 2.6, 3.0. Wow, just barely touch only. Very lucky, this one, very lucky. Just touch. Just nice. Alright, next one. What is the other two coordinates? 12.4, 18 and 13, 18. Okay, so I will go to 18. 12.4. Quite difficult. Need to zoom out a bit. 12.4 to 13. Okay. So 12.4 would be 1, 2, 3. This is 12. 12.4 is here. 13 is all the way here. So this is 3 boxes more likely. So this best fit line is correct. So if your best fit line doesn't pass through these 2 red color horizontal lines, you will lose the mark. It's pretty straightforward one. And some more, we mark on computer, they have a way for them to program this directly onto the marking software. Alright, so this is okay. Worst acceptable straight line, steepest or shallowest line. Lines should be clearly labeled. I don't suggest dash because you also dash your triangle and then you go and dash your second line. Then you got too many dash, then your mark also dash away. Okay, so examiner judgment on worst acceptable line. Must be steepest and shallowest. Marks scored only if error bars are plotted. So if you run out of time and didn't plot your error bar, this one can just throw away already. So let's see. Must pass through all the error bars. So this one, wow, you see here? You see this? Never pass through all. So already this one, 0 there. Don't have, wrong. Okay. So we'll write a big -1 here. Okay. So next, what should we do? Let's read the examiner report. Majority candidates score full credit for plotting the data points with corresponding error bars. Common reason for loss of credit were vertical error bars and drawing large blobs. Do not draw blobs for plotted points. Okay. So both the line of best fit and worst acceptable line are generally well drawn. Candidates should clearly indicate the lines drawn. So let's check if this candidate got labeled. Got lah. Okay, got. So most candidates clearly demonstrated the point they used to calculate the gradient. Okay, so this one is gradient, we'll talk about it later. I want to talk a bit about this last point. This last point you will not get if you did not draw your error bar. So if let's say you accidentally didn't draw or don't know how to draw the error bar or if you've forgotten how to calculate, you will also forget lah. Then this one you will get 0, this one you will get 0. Because this is the mark for error bar. And then this is the mark here. Okay. So this U2 is dependent on U11. Meaning there is ECF. So my suggestion is, if you don't know how to find the uncertainty, you go and put any number that you can reasonably draw. Please don't draw an error bar that is 10 cm long, okay? Any error bar that is more than 1 or 2 cm long, you are wrong. Please go check working, okay? So you go and put something reasonable, maybe 0.4, 0.6, okay? Then you just simply put only. The marker will go nani, take away this mark from you, but got ECF. So then this one, we take the ECF from the table. Okay? So if you don't draw any error bar, then you won't get this mark, and you won't get the mark for the worst fit line. Totally not possible to draw worst fit line. You didn't draw, okay? So let's look at the gradient. So when it comes to gradient, we need the triangle. Let's see what the examiner report say. Okay? Candidates are improving on their ability to select points that are on the line rather than quoting values from the table. So I know people like to do this. They lazy, then they say, Miss, you see this point, pass through this line there. Can I just take the table values? I highly discourage that. How sure are you that your best fit line is correct? Later got range, you will miss the range. Then you very sadness. So please use a nice point from the graph. Like this candidate, he or she used this coordinate and this coordinate, which are not plotted points. Okay, so most could choose a sensible size triangle. A significant number of candidates has power of 10 errors because there is a prefix hiding here. You see this 10 to the power of 6? Ayo. So circle, underline, you cannot highlight in the exam. Make sure you include the 10 to the power of 6 when you calculate gradient. Okay, so I'm going to assume that the candidate is reading it correctly to save time. Although this scanning a bit cacat cannot see the coordinate. Never mind Okay can we assume it's correct. So there is clear demonstration of using coordinate signs. Okay, I mean the method to find gradient. So I like to see working like this. Okay, you find the gradient of your best fit line and your worst fit line, because why? You're looking for absolute uncertainty, so the answer is clearly shown. This one can get 2 marks. Please show your working, because gradient of your best fit line, triangle should be at least half the length of the line drawn, and then the lecturer or the examiner will check the read off in the actual paper, and then do not penalize any kind of error that you transfer from previous your table wrong, all that, never mind. But although that, you still have to have this range. Okay, so we're talking about 1.4 to 1.5. Wow, in the range, very nice. Absolute uncertainty. Method in determining absolute uncertainty would be difference in the worst fit line and the best fit line. Okay, so there are two ways to find your gradient, your uncertainty in gradient. You can take best fit line minus worst fit line, or you can take half the range, steepest and shallowest worst fit line minus and divide by 2. But if you do that, this means you have to draw 3 lines. You have to draw another line from this error bar, from this side, from the left side of this error bar to the bottom. I don't want okay, nobody wants that. Alright, so it's just 1 mark, guys. Do you want to find 2 gradients for 1 mark? Doesn't seem very worth it, right? Okay, so I think this is okay already. You can travel along and look at the calculation. So in this calculation, you're asked to determine the resistivity. So you can see that all this must be here. You must show your working, and you must use gradient value. Okay, so if your answer transfer over once again is wrong, then it's okay lah. The examiner have to take out calculator and press whatever answer you put on top lor. So don't worry so much about paper 5. There's plenty error parry forward. Okay, here this is 1 times 10 to the power negative 6, so this is pretty close. And then I can see all the working here. I can also see the units, ohm meter. Ohm meter negative 3. Nani? Okay, hang on. So the values are correct, so I can give 1 mark here for the values. But what is happening? I am confusion. Unit wrong lor. Okay, a unit. So see it. There. Okay, next, determine the percentage uncertainty in resistivity. Okay, using the worst fit line, you have the value of resistivity, and then you find what is the candidate doing. Okay, so this is the worst fit line, and then you take the actual value of resistivity minus the smallest value of resistivity. Ooh, like that cannot leh. This is very weird. What is happening? I am confusion. What is add 1% from L? Where is L? Oh, the 1% from L. I got a lot of questions. Okay, so let's check the mark scheme. Okay, let's see if the candidate can get mark or not. The actual answer is a percentage uncertainty in gradient plus 1%. So what was the percentage uncertainty in gradient? 0.11 over 1.42. So I'm just going to write here for this candidate, the percentage uncertainty in gradient will be 0.11. Okay, let me zoom in a bit. Divide by 0.42 plus 1%. So 1% is 0.01. So let me poke the calculator first. So the correct answer that this candidate should get, this is 0.42. Did I transfer wrong? I sus something. Is it 1.42? Yeah, 0.11 over 1.42. My bad. So the correct answer, 0.11 over 1.42. Plus 1%. So the actual percentage uncertainty is 0.087 or around 8.7%. Okay, so here cannot now. So why do they say add 1%? Because you take the uncertainty in gradient over gradient plus that 1%. So this is this method. If you don't know how to use the uncertainty identity, go and watch the video. Okay, if let's say you totally stuck, you don't know what to do, you cannot use this method because it is not the max-min method. Whenever you look for absolute uncertainty, not uncertainty from graphing, you have to use the maximum minus the minimum. Alright, so then you need to find the maximum resistivity and the minimum resistivity. If you want maximum resistivity, you need to take the maximum gradient, divide by the minimum length. So this candidate should take pi. What is our maximum gradient? Let's see. Pi 1.42 plus 0.11 divided by 4. The shortest length is, because the length was 1 meter plus minus 1%. So you minus 1% on 0.99. And then this one will be pi 1.42 minus 0.11. You will take the minimum gradient and the maximum length. Okay, so minimum gradient is 1.42 minus 0.11 and the maximum length is 1.01. Wow, a lot of work for 1 mark. Yeah lor, can you please use identity? This is way better. Okay, so hence the percentage uncertainty in resistivity will be equal to, wow, need to press a lot of calculator. Okay, let's try. Okay, so after pressing calculator, you will find that the maximum value is, let me write a bit. Maximum value of resistivity is 1.214, minimum value is 1.190. I would just like to take this opportunity to gently remind you that just because you are looking for the maximum value of resistivity doesn't mean that you take max divide by max. Understand, right? Because this is the numerator. So if you want the biggest number, you will take the biggest numerator, divide by the smallest denominator. So up here must be the biggest one, down here must be the smallest one. If you want the answer to be the minimum, then up here must be the smallest one and down here must be the biggest one. Think a bit. Okay, or if you really cannot, you go and try all 4 options, then take the big one minus the small one, then you waste so much time for 1 mark. Okay, anyway, how do we find the percentage uncertainty now? Is the answer comparable? Okay lah, I write here lah, I need a bit more space. Miss, where so much work? Alternative method, highly don't recommend. This is a fail safe. Okay, so now if you want to find the uncertainty for this one, you will just take the percentage uncertainty. The absolute uncertainty now would be half 1.214 minus 1.190, half the range, divided by the actual value of resistivity. So let me take a peek because I don't remember that after calculating so many things. Oh, 1.1 times 10 to the power of negative 6. Okay. So 1.1 times 10 to the power of negative 6. But these two also got times 10 to the power of 6, right? Because you go and check with the 1.4. So normally when I see a prefix here, I expect to see a prefix up here lah. So this 0.11 and 1.42. You see, when you can use identity, the prefix cancel out. But you cannot use identity, now you go back and check the prefix already. Okay, prefix was negative 6. Okay, very nice. Meaning this 1.42's prefix is negative 6. Okay lah, scared forget, I write here. Negative 6. Negative 6. Come here. Negative 6. Times 100%. So the negative 6 and the negative 6 will go bye-bye. And then if you press your good friend Casio the calculator, I am partially praying that the answer is the same or close to each other. 0.012. So this will be 0.012 divided by 1.1. So what I got is 0.010 or 11. So this one is 1%. Wow, quite far. Did I press things wrongly? Oh well. Right, so after some checking, some painful checking, I will comment later on this method lah. As you can obviously tell, I do not like this method and do not recommend. But this one, I transfer the numbers wrongly. It was supposed to be 1.09, okay? Can? Okay, and by the way, the prefix continues like as usual. So I'm just going to cross off this one. This is 1.019. So after you minus, I'm just going to rub off this one lah. Okay, so after subtraction, this will be... Nothing is working already. Hang on. After subtraction... okay, hang on. My calculator gone away again. Okay, so nothing works at night. 1.019. This is 1.214, 1.019 divided by 2. This is 0.0975. Okay, so after you press your calculator, so this is how I know it's wrong lah, because I have the real answer is 8.7. So my answer should be close to that 8.7. Okay, so I times 100%. Alright, the negative 6 cancels out, and this will be 8.86%, which is close enough, and I can accept this as 8.9%. Okay, so you can see these two is quite close. Of course, they are not going to be identical because they are different methods. And this method is a bit more legit lah, because you are using it from calculus. Okay, so let me show you what the examiner report say. There was a good recognition that the percentage uncertainty of resistivity is the sum of the percentage uncertainties. So sum of the percentage uncertainties of the two necessary components in the equation. Okay, so you need to have length and then you need to have gradient. Candidates attempting to use the maximum minimum method tended to make mistake by not clearly showing where their data originated, or by using incorrect combinations of maximum and minimum value. Even the examiner report do not suggest you use the max min method. So I'm just going to put a big bracket here and draw out and do not recommend. There are so many pitfalls here. Okay, number one, the calculation requires more pressing. The more you press, the more you have errors. So I tend to want to avoid this because, as you can see, I will make errors. It's 1:30 a.m., so it's to be expected. Alright, then second problem is whenever you forget to transfer a prefix, second error, second pitfall. Third problem here is what happens if your gradient, like you didn't take max min, you go and take max max, or you take min min. So this is an example of incorrect combination of maximum and minimum values. Alright, so much work, 1 mark. Please use identity, especially, so it's worth to know the identity, save you a lot of pain. And anyway, generally if I see the method is wrong, I don't have to think so much one. If I'm marking, I don't have to think, I just put X. Don't worry, second and third one will be very fast already. Okay, wait and then you can see this part when you find the value of resistivity, the working of the answer must be clearly shown. Okay, equation should be quoted, followed by correct substitution of numerical values. You can see repeatedly they mention that you have to show your working, show your substitution. If you don't show, that means I don't know how you arrive at that value. I'm very happy to give 0. Many candidates did not give correct unit, including this one, and several candidates did not give any units. So sad. Okay, then some, there are a power of 10 errors in the gradient. So this one will also have a power of 10. Okay, so if you don't get this range right, then a bit sad lah. Alright, okay, correct unit and correct power of 10. So if you will lose this C3 mark if you didn't have the correct power of 10, which is negative 6. So you can still get C2, but you will lose C3. Okay, especially if you calculate things wrongly from the beginning. Okay, final part. This part you find the value of R. Again, calculation is clearly shown. R has to be in the range of 25.5 to 28.4. Okay, can. This one 1 mark. Allow ECF, sure. Can. So if it's a power of 10 error, let's say for example you didn't transfer your power of 10, then your answer won't be this number. We will allow. So these POT are all power of 10 error. So this one, if you didn't convert, then can. But then here we will penalize your power of 10. If you scroll up here, where else they talk about the POT? So when you find gradient, if you don't have the power of 10, we will still give you mark. So there's only one point where your power of 10 is subtracted at this point, which is when you calculate the value of resistivity. 5 marks have to work so hard. Take a breath. We'll look at some trees. Okay, next. Okay, there we go. So we will not penalize you from POT. Absolute uncertainty in R. Okay, how do we find absolute uncertainty in R? You take the, this one correct. Percentage uncertainty in gradient plus percentage uncertainty in the diameter, because that was how you find R in the first place, what you see here. So percentage uncertainty in gradient times 2 times the percentage uncertainty of the diameter. Okay, correct. So this is the absolute uncertainty. If I see the absolute uncertainty in R, the method is correct, you will get your mark already. And the percentage must be greater than 8.6. So now I need to poke calculator again to make sure that 4.4 divided by 26.8 is greater than 8.6. Based on this candidate's numbers, this is 16%. So it is greater than 8.6. In fact, 8.6 here tells me that my percentage uncertainty is correct on the top, because I got 8.7. Alright, so this is okay. So let's total up the marks. There. 1, 2, 3. So this is 3 marks. So here -1 now. Here -1. 3 marks. 4, 5. Graph everything. So for the graph, this one is 1 out of 2 because of error bar problem, didn't pass the error bar. This one is 2 out of 2. This one is 2 out of 3 because of the decimal point problem. So this one is 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 out of 15. Can do better, but this candidate is pretty okay lah. Alright, again, there's a part where I didn't penalize mark, which is this one SF. So could drop to 10, 10 out of 15. With more practice, people can get quite high. Alright, so let us speed mark to the final two, which I might or might not leave in the video. I don't know. What is life? Okay, so this one is correct. Next. Table values. Okay, so the table values are okay. Everything is written to 3SF. The absolute uncertainty kind of follow the decimal point. Okay, correct. This one transfer correct. So this is 3. Very nice. Let's continue. Plot graph, include error bar. Okay, I am very hopeful because I see the correct working, and this one is a direct subtraction. Decimal point follows, so this one should be correct. So if I'm marking an actual exam paper, I will check the read off lah, but for brevity's sake, I will not today. So there are clear labels, which I like what I see. Error bars are, let me zoom in for you to see. Error bars here are clearly shown. Okay. And did the candidate pass through all the error bar? Got okay, triangle also I can see. Got use plot. Aiya, you use plotted point. Why you use plotted point? So now you see another plotted point here. So here you're at the mercy of the examiner lah. I shall be slightly more savage and take away 1 point because plotted points are being used. Okay, because generally, as you can see from the examiner report, they do not recommend that you use plotted points. Stay safe. Okay, so this one got clear substitution of working or not? What do you think? Do you know which equation he used? If you go and look at the previous examiner report, it says here, when calculating the value of resistivity, this one. It is vital that the working for the answer is clearly shown. Equation should be quoted, followed by correct substitution. Did that candidate quote the equation? No, okay lor. So I can minus 1 mark here. What equation did you use? What is happening? I don't know. But thankfully, fall between the range and the unit is correct. The correct power of 10, I can give 1 mark. Okay, so this is 1. Next. Okay, so we're taking percentage uncertainty, 0.120, 1.41. Let me check. Okay, correct. Plus 1%, because this is 1%. Okay, this is no problem. You see this working, or you see this, and then you compare to the pain that we've been through for the past 10 minutes. Make better decisions for yourself. I know my decision. Too bad I'm not a candidate. Okay, so like that lah. Oh, well, now know how to show equation this person. Aiyo, maybe he got smacked in the head, woke up already. Okay, so I see the substitution. This one is within the range. Just don't know. Okay, then you see very smart. You see he find the percentage uncertainty. I take 9.5%. Where's the 9.5% from? Oh, here. Okay. Plus 1%. Where's this 1% from? This one I understand. This is 2 delta D over D, right? This one, this nani? So I can choose to say that I do not understand this. You might understand. Okay, so I don't care. I don't understand. I'm chasing time. So this one in the range, I can give you 1 out of 2 because I don't know what is this. Like, what are you doing? Why you add 1%? Where the 1% from? From this one? You didn't show fraction also? I don't know what is happening. This one is this one? I don't know. Basically, IDK. If I have to go and figure out what you are dividing, I can choose to not give you marks as the examiner. Because working not clearly shown, as repeatedly emphasized in the examiner report just now. Okay, so 1, 2, 3, 4. Graph are all okay. 5, 6, 7, 8. Okay, so we need to check whether it passed through the certain points, which I will not check. I guess if I remember, I can check. This is 13, this is 18. So it's these 3 points. Got passed, these 3. And then bottom here is 4 here. Okay, got pass. So the best fit line pass. Worst fit line also pass. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So marginally better. 12 over 15. Okay, let's see if we can learn anything from the last sample script. Okay, this one was the one that I used in the discussion video. You can see working is clearly shown. It's a very good sign whenever someone marks this and see the candidate write things clearly. A good handwriting. And you can see they even reminded themselves to transfer the SF appropriately. So correct now. Got identity here for her to double check, which I also recommend. If you are using an identity, you write at the side so you can always double check. Okay, so this one is all pretty good. Alright, so full mark now. I'm going to assume that everything here is correct. Okay. Can. Let's check the graph. Okay, graph are properly labeled. And I see 2 triangles. Neat and nice. Did she use a point? She did not. She used this point and this point, which is not a plotted point or not a table value. Use this point and this point, not table values. Very nice. Okay, nothing to minus. Even circle the prefix to remind herself there's a prefix. Okay, now you see gradient equal to this one. Then she substitute the value of gradient 1.42. Now see here 1.42. But you see, I tell you, it's better to just take this 1.4. Because then I'm like, why 1.4 should put 1.42? Then I need to do the extra step to see here. So I recommend if you want to take 1.42, then you take this whole thing 1.424. Okay? Alright, so you can see how quickly I can mark through this candidate because the candidate is a pretty good candidate. Okay, so now this one is correct. Although the doesn't really look like lah, if I have anything to nitpick about. But 2 to 3 SF, your answer. Okay, and uncertainty for gradient 0.20, 1.4. Okay, sure. A little bit big, but it is what it is. Because she took 2 SF. If she takes 3 SF, the uncertainty will drop 1. Okay, so here, clear working and clear substitution. Okay, obviously she got checked the mark scheme already, so she knows the range. Okay, and you can see this is what I'm looking for, guys. Please write this. Help a teacher out. And you will notice that the previous candidate could have gotten marks because this is your 1%, and I didn't understand where the 1% came from because I could pretend I didn't know. Okay, so this is what I'm looking for. I'm satisfied and happy. So she found the percentage uncertainty 25%. She's so nice. She knows that I need to check the percentage uncertainty is more than 8. So she thought about me. And she wrote the 8. Very nice. I'm thinking about her and I'll give her full marks. So what did she get? Oh, 15 out of 15. Very nice. This one deserves a sticker. So what did we learn today? Writing your answers is important. Paper 3 and paper 5 are siblings, so they care about the same things. If you show your working clearly and everything is properly presented, you can get full mark very easily. And it's not like the working is long. It's not. It's just that if you decided to go the max min method, then you might max min your way into confusion like I myself did just now, because I myself am not familiar. Okay, so that's it for this recording. Hopefully you've learned something today. Go mark your own paper and savage your own self and see. Okay, be a bit strict. Pretend you are the strictest examiner possible. I wish you the best and I'll see you in the next video. Bye-bye.